Hey guys, I'll tell you what, there are very few topics that can totally unlock your math potential the way that exponents in general can. Like the moment that you really master your exponents, your whole math career just takes off. You start to crush your algebra classes, you start to crush the SAT, the ACT, all sorts of things like that. Just like this one single topic just blows the top off of your potential as a student. So today we're going to really get into negative exponents. Okay, so first let's set the stage. Let's recap what we know about exponents up to this moment. We've always defined exponents as simply being like repeated multiplication. Okay, repeated multiplication. In other words, the exponent of a number says how many times we want to use that number in multiplication. So it's been real straightforward. If you saw 5 to the third power, well, we want to repeat that 5 3 different times. Whoa. There we go. And 5 times 5 times 5 makes 125. So that's all this is an indicator of how many times we want to repeat that multiplication. And here it is, just a beautiful graphic here. We've got, certainly we've got our exponent up here. This number here, the 2, is called my base. Okay, so we're going to use that terminology and refer to the base quite a bit here today. And again, just some other properties that we've seen leading up to this point. We have that product property that says, hey, you know what? If you're trying to multiply one term by another and you got the same base, all you got to do is add those exponents. Or the quotient property says, if we're dividing these terms, all you got to do is subtract the exponents. Then you got your power property where you're going to multiply those two powers together. And then, of course, anything raised to the 0 power is simply going to be a 1 no matter what. Okay, and then we walk in to negative exponents, okay? And we're going to try to explain why a to the negative x is equivalent to 1 divided by a to the x. So let's start with this as our working definition here, okay? For a negative exponent, any term raised to a negative exponent is equal to the reciprocal of that term raised to a positive exponent. What in the world does that mean? Okay, so right out of the gates here, here's a term or a base, and it's raised to a negative exponent, right? So what I want you to do, first of all, is visualize that base as a fraction. So in this case, the base wasn't a fraction, but I can visualize it as a fraction, right? And all we're going to do is reciprocate that base, okay? And now the exponent is what? Positive. Okay, and of course that last one could be rewritten this way right here. So we're going to just reciprocate that base. And the moment we reciprocate that base, that exponent becomes positive and we are golden. So here's one cool way to just think of a negative exponent as like this signal or this trigger telling us to flip the numerator and the denominator of that base. So here's one. We've got ourselves our base. We recognize the negative exponent. So all we're going to do is reciprocate or flip the numerator with the denominator. And now the exponent is positive. How sweet is that? So all we got to really focus on is finding the reciprocal of that base. All right, so we're going to jump right in here. Okay, so right now my base is not a fraction per se, but I could visualize my base as 4 over 1. Okay, now I'm going to switch the numerator with the denominator. And the moment I do that, my exponent becomes positive. And if you want to, you could think of this as 1 squared all over 4 squared. So we're getting 1/16. And I think maybe this is a little counterintuitive. Maybe if I had asked you at the beginning of the video, what do you predict, how these negative exponents are going to work? You probably would have assumed that maybe the answer is going to be negative. And what you're going to see here, the common trend is none of my answers are going to be negative. In fact, they just become fractions, 99% of the time. So a negative exponent does not mean my answer is going to be negative. In fact, it's quite the opposite. Okay, same idea here. I don't have a fraction yet, but I could visualize that base as a fraction. And the moment that I reciprocate it, where I switch the numerator with the denominator, that exponent becomes positive. So we've got 1 to the 4th all over 3 to the 4th. And you know what? And I want to really talk about our handwriting because I'm not real happy with mine there. For instance, that one, it's almost like I just want to, if anything, err on the side of making the exponents too small, too high, as opposed to letting them get droopy and saggy. And then all of a sudden, what should be an exponent, just looks like a regular integer. Okay. And so once we finish that, we'll get 1 over, and then 3 times 3 times 3 times 3 makes 81.